This lesson is working with the quadratic formula and the discriminant. So when we're working with the quadratic formula, there is an equation that you need to know here, and the equation is negative b plus or minus the square root of b squared minus 4ac. All of that is divided by 2 times a. Remember, when you have a quadratic function, it's in the form of ax squared plus bx plus c, and you're using the formula here with your quadratic equation to help you find your x values or your zeros. So let's just get started right away with some examples using the formula. So here we have negative 3x squared plus 5x plus 2 equals 0. So we first need to identify our a, b, and c. So our a is going to be negative 3, that's in red. B is going to be my 5, that's blue, and my C value is 2, which is in green. So then I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So I'm using this formula and setting my values up in this formula. So I'm going to substitute negative 3 for a, 5 for b, and 2 for c. So this is how the setup's going to look. You have negative 5 plus or minus b squared, so 5 squared minus 4 times your a is negative 3, times your c, which is 2. All of that is divided by 2 times a, which is 2 times negative 3. So now what we're going to do is we're going to simplify this down. So we'll leave negative 5 outside of the square root symbol. Negative 5 plus or minus 5 squared is 25. Then negative 4 times negative 3 times 2 is going to give me negative 24 here. So it's 25 minus 24. All of that is over negative 6. So when we break that down even further, it's going to be negative 5 plus or minus 25 plus 24 is 49, divided by negative 6. Then we take the square root of 49, which is 7. So what we have then is negative 5 plus or minus 7 divided by 6. We need to then simplify a step further by setting it up as negative 5 plus 7 divided by 6, negative 5 minus 7 divided by 6. So you'll get 2 answers for x. X is going to equal negative 3, or x is going to equal 2. And that's how the quadratic formula works. So you need to remember the formula, and then from there, it's almost like solving using orders of operation, working with square root to get it down to solve for x. Let's do another example here. We have 2x squared minus 8x plus 1. So first we need to identify our a, our b, and our c. So my a value is going to be 2. My b value is negative 8. And my c value is 1. And then I'm going to set it up using the quadratic equation, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So this is what we have here. Now notice my b value is already negative, so outside of the square root sign it's going to be a double negative. So a minus negative 8 plus or minus negative 8 squared. Don't let that negative b get confusing in the square root. You cannot take the square root of a negative value, but when you have negative 8 squared, that's negative 8 times negative 8, which is going to give me a positive 64. So just something to think about there. Negative 8 squared minus 4 times 2 times 1 times a times c all over 2 times a, 2 times 2. So now we simplify this down. So what we have here is negative and negative is positive 8, plus or minus 8 squared is 64, minus 4 times 2 times 1 is 8. So 64 minus 8 all over 4, because 2 times 2 is 4, equals 8 plus or minus 56. How did they get 56? Well, 64 minus 8 is 56, divided by 4. We can then simplify this down a little bit further. So we have 8 plus the square root of 56 divided by 4, and 8 minus the square root of 56 divided by 4. When we take the square root of 56, it's not going to give us a whole number. It's going to be giving us a decimal. So when you're doing this on your calculator, just be aware of that. So what you'll end up with is when you add 8 plus the square root of 56 divided by 4, you get 3.87, round to the nearest hundredths place value. And then 8 minus the square root of 56 divided by 4 is 0.13. So my x values are going to be 3.87 or 0.13. The other topic that is discussed in this section is called the discriminant, and the discriminant is when you're looking at just what's inside the quadratic formula, that b squared minus 4ac. So if the equation is in standard form, the discriminant of a quadratic equation is b squared minus 4ac. The quadratic equations have 2, 1, or no solutions. So this is something that you really need to know. And then you can determine the number of solutions of a quadratic by evaluating the discriminant. So when you're given a quadratic equation, and when you use the formula to find the discriminant b squared minus 4ac, when you simplify that down, when your situation, when your value is greater than 0, that means it has 2 solutions, meaning it has 2 zeros. 2 places on the x-axis that it crosses. If b squared minus 4ac is equal to 0, then we have 1 solution, which means you have 1 0. That's what it means. 1 value that falls on the x-axis. And then when your discriminant value is less than 0, then that would be a no real solution. So that means that there's no zeros, no value that falls on the x-axis. So here's a chart that just kind of shows you how the discriminant works. So we have here an equation, x squared minus 4x plus 3 equals 0. We have our a value is 1, b value is negative 4, c value is 3. You set up using the formula b squared minus 4ac. So negative 4 squared minus 4 times 1 times 3 times a times c. That simplifies to 4. Since this discriminant value is positive, then it's going to have 2 real solutions. The second situation, we have x squared plus 2x plus 1 equals 0. A is 1, b value is 2, c value is 1. Again, we use the formula b squared minus 4ac to help us solve this. So b squared 2 squared minus 4 times a, which is 1, times c is 1. That simplifies to 0. When you get a discriminant value of 0, then it's going to be 1 solution. The last scenario here on this chart, we have x squared minus 2x plus 2. Our a value is 1, b value is negative 2, c value is 2. Using the formula b squared minus 4ac, we take negative 2 squared minus 4 times 1 times 2, that simplifies to negative 4. So since my discriminant is negative, that would be a no solution. If you notice too, there's a graph for each situation. It's showing the 2 zeros, how the graph crosses the x-axis twice. Here's the 1 solution. We have 1 point that falls on the x-axis, and then here's my no solution. There's no zeros, no values that fall on the x-axis. Here are a few examples working with the discriminant. So for a, we have 2x squared minus 2x plus 3 equals 0. We first label our a, b, and c. A 2, b negative 2, c is 3. We set it up using the formula b squared minus 4ac. Then you just substitute it in and you solve. So this would simplify to negative 20. Negative 2 squared is 4 minus 4 times 2 times 3 is 24, which is negative 20. That's going to be a no solution since this is negative. It's no solution. Next one, we have x squared plus 4x plus 4. So again, my a is 1, b is here 4, c is 4. Setting it up using b squared minus 4ac, you substitute your a, b, and c values into the formula to simplify to get 0. Since this is 0, there would be one solution. For c, we have x squared minus 9x plus 4 equals 0. A value is 1, b is negative 9, c is 4. Using the equation b squared minus 4ac, we set this up and solve to get 65. 9 squared is 81, 4 times 1 times 4 is 16. 81 minus 16 is 65, so this is positive, which means there's going to be two solutions, two real solutions, and that is what you do to solve the discriminant.